Good morning, champs. Everything worked perfectly with the residue theorem until the pole sat exactly on the integration path, and this creates a serious problem. Today, we will understand how the Cauchy Principal Value fixes this issue. Consider the integral CPV, integral from minus infinity to infinity of 1 over x dx. At first sight, this integral does not exist. Why? Because the function 1 over x has a pole at x equals 0, and we would be integrating directly through the singularity. So instead of integrating through 0, we approach the pole symmetrically from both sides. We define the limit as rho goes to 0 of the integral from minus infinity to minus rho plus the integral from rho to infinity. This is called the Cauchy Principal Value. Now let's understand this geometrically. Normally, for residue theorem problems, we integrate along the real axis and close the contour with a large semicircle in the upper half plane. But now, the pole at z equals 0 lies directly on the contour. That is not allowed. So we modify the contour. We cut out a small semicircle around the pole. This tiny detour avoids the singularity. Now the contour consists of 4 parts: the large semicircle, the left real segment, the right real segment, and the small semicircle around the pole. Now consider the complex function 1 over z. Inside this modified contour, there are no poles anymore because we removed the singularity from the region. Therefore, the integral over the entire closed contour is 0. Now let's analyze the different pieces. First, the large arc. We parameterize the large semicircle by z equals re to the it. After substitution, everything simplifies beautifully, and we get I times pi. Now the small arc. Notice carefully. This small semicircle is traversed clockwise. That changes the sign. After parametrization, we obtain minus I pi. And this is the key insight. A full circle around a pole gives 2 pi I times the residue. A half circle gives only pi I. And clockwise orientation introduces a minus sign. Finally, we combine everything. The large arc contributes plus I pi. The small arc contributes minus I pi. They cancel exactly. Therefore, only the two real integrals remain, and their sum is 0. Taking the limits gives the Cauchy Principal Value integral from minus infinity to infinity of 1 over x dx equals 0. And this is the fundamental idea behind principal value integrals. Even though the ordinary integral diverges, the symmetric divergences cancel perfectly.